Hi, this is Martijn from SkyGeo. Welcome to our Fringe 2021 workshop on InSAR for the built environment. I'd like to talk to you about a specific case study for predictive maintenance, the application of InSAR to urban pipeline networks. And the area we're talking about here is the area where Stedin delivers natural gas to their customers, hundreds of thousands of customers, and they are roughly outlined by these red squares. And they are superimposed on the bottom-down skies, which is the nationwide subsidence map for the Netherlands. And if you know that red means subsidence and green is stable, then you can already see that the area which Stedin delivers gas is an area that has lots of subsidence. So the main challenge here is because of all the subsidence, the roads and the gardens in that area are going down slowly, but the houses remain mostly stable. So this creates a differential settlement between the house and the pipeline and is a risk for damage. Normally, the historic way to assess this potential damage situation is by digging a hole, which is A, costly, but B, also quite a disturbance to the people living at home, and the city wants to avoid as much of that as possible. So the challenge is, how can you know about this situation, this risk, without actually having to dig a hole? What SkyGeo did is process thousands of terrestrial extract map images, creating more than 100 million PS and DS points, and almost 70 gigs of data. And then together with Stedin, we worked on integrating this data actually into their normal workflow, which is what Ivo Visser from Stedin is going to tell you about.
Thank you, Martijn. The data we receive from SkyGeo we plot on a map together with our asset data. In this map, the black lines represent our mains, and you can see that the mains do not intersect in all locations with a measurement. This is something we would like to have to be able to predict the probability of a failure on a main and on a service line. So we do a post-processing step interpolating the data to get measurements across the entire service area and to be able to make these intersections with our assets. We try to estimate standard deformation curve shown in blue in the graph, and we have the linear deformation trend in the time series from the PS and the DS InSAR points, and based on the age of the area we try to estimate the total deformation the asset has received. To test this method, we did a test on service line projects, multiple of them, where in normal projects we used to do an entire neighborhood, so replace all 800 or maybe more service lines. And now we try to predict all of them and see what they could handle with respect to deformation, and then see which service lines really need to be replaced based on the deformation and which ones were still safe. In this project, there were only the red and the orange ones have been replaced together with the yellow one, saving us per project approximately 80,000 euros a week. So with this really nice business case, we decided to integrate this data into our models. Normally we do for our risk analysis, survival analysis, one for service lines where the deformation is a very important parameter, and one risk model for mains where a derived product from the deformation data is used, the slope data, which highly correlates with the probability of a failure. So this means we can use InSAR data to assess the quality of our service lines and mains, reducing inconvenience for customers because we do not have to dig to make the assessment. We save money because we don't have to replace all our assets, and this money we can invest again in improving the safety in other areas.
Thank you, Ivo, and thank you all for listening. And remember, SkyGeo is hiring, so please reach out to send us your resume. Thank you.